In this lecture, we'll talk about addition property of equality. We will go over identifying the linear equations using the addition property of equality. We will simplify equations and then use the addition property of equality. Let's look at what is a linear equation in one variable. It's ax plus b equals c, where a, b, and c can be real numbers. They can be positive numbers, negative numbers, decimals, or a fraction. The only restriction is we cannot have a to be 0, because if your a is 0, then you will lose the variable x and then there will be no linear equation. Let's look at some of the example of linear equation before we start on learning how to solve them. These are the example of linear equation. 3x plus 5 equals 8, 2y plus 9 equals negative 11, 6m minus 2 equals negative 7 plus 4m. As far as you're having the same letter, you can use that more than once for a linear equation. I have also used one of the fraction on the bottom just to show you m minus 3/4 equals 1/2. That's also a linear equation. M equals 12 is also a linear equation. On the right side of the screen, I will show you the one which are not linear equation. X squared plus 4 equals 9 is a not linear equation because the power on x is 2, which is squared. So for linear equation, the highest power that is allowed is 1. 8 over y equals 5. The second restriction, you see that you cannot have the letter underneath the denominator. You can have the number underneath the denominator, but not the letter. Another example, z cubed plus 6 equals 27. As you can see, the power is one more time higher than 1, and that is not allowed for linear equation. So my right side is not linear equation, and my left side are all linear equation. Now let's look at another definition before we jump into how to solve them. Equivalent equations. Equations that have exactly the same solution are equivalent equations. I'm going to show you 3 examples here. X plus 2 equals 7. What would you replace your x by so you will have 7 on both sides? So I guess the answer is 5, because 5 plus 2 is 7. Both the sides will be same. X minus 1 equals 4. What should I replace my x by so my both the sides are 4? The answer again is 5. 5 minus 1 equals 4. One more. X plus 7 equals 12. What should I replace my x by so I get 12? Once again, the answer is 5. 5 plus 7 equals 12. So as you can see, all these 3 equations, they look different, but in all of them, the x equals 5, which is the same solution. These kind of equations are called equivalent equations, where they look different, but the solution is same. Let's understand the addition rule of equality now. Here's the balance, and z equals 8, meaning it's a balance right now. If I'm adding a positive 6 on one side, to keep the balance, I should add positive 6 on the other side as well. Now, my new equation will be z plus 6 equals 8 plus 6, which is 14. Now, this new equation, which arrived from the original equation, z equals 8. Now, remember, z equals 8 will be only true when your z is 8, because both the sides will be 8. In the new equation also, I must replace my 8z by 8, because 8 plus 6 will give me 14. And therefore, we saw that we can add the same number to each side of an equation without changing the solution. That is addition rule of equality. Now, can we try by subtracting the same number and see if that still works? Let's give it a try again. I'm going to take a same beam and start with z equals 8, as I know 8 is a solution. This time I'm going to subtract -5 from both the sides and get my new equation as z minus 5 equals 3. Now let's see, what should I replace my z by so I get 3? And once again, the answer is 8. 8 minus 5 equals 3. So I can also subtract the same number to each side of an equation without changing the solution. So addition property of equality allows us to either add the same number or subtract the same number on both the sides of the equation without changing its solution. Now, these are the end result you might see once you solve the equation. What is the solution of negative x equals 5? Now, anytime the variable is a negative number, you always have to switch the sign. So if I make x to be positive, you must change the sign for 5 and make it negative. Let's try one more. Let's see if you solve the solution and in the end, you got negative y equals -7. One more time, y variable is negative. I must change the sign of a negative y into positive y, and similarly, I will change my -7 into +7 instead. So the key thing to remember here is your final answer should always be a positive variable equals the number. The variable must be positive. The number can be positive or negative. This is how we want our end result when we solve any linear equation. If it's already positive variable, you're not supposed to change anything. Let's look at the example. R plus 12 equals 29 is our first example on how to solve linear equation. I want R to be alone, isolated. So in order to make R alone isolated, I must remove positive 12. How can I do that? By doing the opposite of positive 12, which is negative 12. If I do negative 12 on one side, to keep my solution same, I must do that on the other side as well, according to the addition property rule. So here we go. I did a negative 12 on one side, the same thing on the other. 12 and negative 12 will cancel each other out, become 0. R plus 0 is simply R. And 29 minus 12 gives us 17. This is our final answer. You can always go back and check it by putting 17 in place of R to see if both the sides come out to be 29. It should. Here's the second example. P minus 25 equals -18. I want P to be isolated, so I must get rid of -25. Opposite of -25 is positive 25. I must add positive 25 on both the sides. By doing it, I get rid of -25, and that becomes 0. So therefore, P equals -18 plus 25 will give me +7. Let's try some more examples. -3 equals a plus 2. This time, my a is on my right side, which I want to be alone. I must get rid of the positive 2 this time. The opposite of positive 2 is a -2. You must do that on both the sides of an equation. By doing it, a 2 and a -2 will get canceled. -3 and a -2 combining will give you -5. And therefore, you can write the answer to be -5 equals a or a equals -5 will be your choice. Here's another example. 22 equals -16 plus r. I want r to be isolated or alone. I must get rid of the -16. Opposite of -16 is a positive 16. I must that to both the sides of an equation. -16 and 16 will cancel each other out, become 0. And therefore, by adding 22 and 16, I'm getting 38. One more time, you can write the answer R equals 38 or 38 equals R will be your choice. Here's another example. In this example now, I have x terms on both the sides of an equation. 3 minus 8x equals negative 9x minus 1. You have two choices here. Either you can eliminate negative 8x or negative 9x. I usually go with the smaller number. So if I have to choose which x I will eliminate, negative 8 or negative 9, I will choose negative 9. But either or should be fine. Opposite of negative 9x should be positive 9x. I must add the 9x to both the sides of an equation. By doing it, you will see that the 9x gets eliminated, and I end up having 3 plus negative 8x plus 9x is 1x, which is simply x, equals negative 1. Now I have only one x instead of 2, but that x must be alone. So I must get rid of the 3 which is attached to the x. Opposite of 3 is negative 3. I must subtract negative 3 on both the sides of an equation. And therefore, I can eliminate 3 now, and x equals negative 1 and negative 3 combining will give me negative 4. And that's my final answer. Let's look at another example. In this example, you must combine the like terms on the either side first. I will not subtract any b's from either side because I have 4b and a negative 8b, which I must need to combine. And I have negative 3 and a positive 1, which I need to combine. So combining the like terms, 4b and a negative 8b will give me negative 4b. Negative 3 and a positive 1 will give me negative 2. And that equals on my right side, there's nothing to combine, so I will bring the whole two terms as is, negative 5b plus 9. Now the b's are on the opposite side of an equation. You have to decide to get rid of one of them. I usually get rid of the smaller one, negative 4 and negative 5. Negative 5 is a smaller number, so I will get rid of negative 5b by adding the 5b on both the sides. By doing it, you will see that you can get elimination of negative 5b and 5b, which is 0. So I will end up having negative 4b plus 5b, which is a 1b, b minus 2 equals 9. I want my b to be completely alone. I must get rid of the negative 2 now. I will do the opposite of negative 2 by adding the 2 to both the sides. This way you can get rid of the 2 and you have b alone by itself. That equals 9 plus 2, 11. So your final answer will be equal b equals 11. So to remember the steps, I put the steps in the next slide. So this is how you follow. You always collect the like terms on either side of the equation first. Then make variable term on one side and the number term on the other. This is the time we get rid of one of the x's. And then we can go ahead and get rid of the letter number and then make the letter all alone by itself. So in the end, we end up having x equals a number. These are the steps you will follow for the remaining examples. Here's another example. Now in this case, I have a parenthesis. Let me get the pen here to show you that how I'm going to use a distributive property. So I will have, let me just get another color. So here are 8r minus 3. There's nothing outside here, so there's nothing to do. You can just basically remove the parenthesis. But in the second one, I will have negative times positive, which is negative 7r, and negative 7r plus 1, which will become negative 1. So using a distributive property, I get 8r minus 3 minus 7r minus 1. Now I must combine the like terms. So which are the like terms? The 8r and the negative 7r are the like terms. The negative 3 and the negative 1 are like terms. We must go ahead and combine. So combining the like terms, 8r minus 7r, which is 1r, which is r, and negative 3 and a negative 1, which will be negative 4, equals negative 6. I want r alone isolated. So to do that, I must get rid of the negative 4. I must add positive 4 on both the sides of an equation. And therefore, you can get rid of the 4 from both the sides, and r equals negative 2 is your final solution. Let's try one more. One more time, distributive property. Let me get the pen here. 4 times 6 is 4k. 4 times k is 4k. 4 times negative 6 is a negative 24. Negative times 3k, negative 3k. Negative times positive 2, negative 2. So first of all, we must get rid of the parenthesis by using a distributive property. And that's how we get it. 4k minus 24 minus 3k minus 2 equals negative 5. Next thing is to combine the like terms. So we will combine the 4k and the negative 3k, combine the negative 4 and the negative 2. This will give us 4k minus 3k is 1k, k, minus 24 and negative 2 is negative 26 equals negative 5. Now you want k all alone. So I'm going to add positive 26 to both the sides to get rid of the negative 26. By doing that, we will get k equals positive 21, which is our solution. The negative 21 and a positive 26 will get canceled. So hopefully you understand the linear equation. If needed, you can repeat the lecture again.